Continuing on lesson 1. Okay, this time we're going to look at some derivatives of some transcendental functions like e to the x and natural log of x. To do that, please let's first assume the property that I have written here. The limit as x goes to 0 of e to the x minus 1 over x is equal to 1. So what we want to do now is, if this would show up, what we want to do now is derive the derivative of e to the x. So how do we do that? Well, we don't have any book of memories yet, so the only thing that we can do is say that the derivative with respect to x of e to the x is, we'll use the definition, the limit as h goes to 0 of e to the x plus h minus e to the x, or h. Then if I rewrite that, it's going to be the limit as h goes to 0, factor out. Before I factor out, let's review the property. See, properties of exponents, I wrote that as e to the x times e to the h. Now I'm going to factor. So this is the limit as h goes to 0. I'm going to factor out an e to the x, which leaves me to e to the h minus 1 over h, which gives me e to the x times the limit as h goes to 0 of e to the h minus 1 over h. Then that property that we assumed in the beginning told me that's equal to 1, so the result is e to the x. Crazy, right? That the derivative with respect to x of e to the x is itself. Wow, digest that for a minute. That's telling me, let me change the color here. Here's e to the x. That's telling me that the slope of the tangent is equal to the value of the function at any value of x. So if I drew a tangent here at x equals 0, the value e to the 0 is 1. That's also telling me that the slope at 0 is equal to 1. Pretty neat. It's also important to note that the domain of this is that x can be any real number. Okay, now let's take a look at the natural log of x. In effort to do this one, we're going to use a similar strategy that we did for the inverse trigonometrics. So we're going to let y equal the natural log of x, where according to this function, x is already restricted to being greater than 0, and our goal is to find dy dx in the scenario that y equals natural log of x. So we are going to rewrite this by the definition of exponential and logs. X equals e to the power of y. Now we're going to use implicit differentiation. The square root of x with respect to x is 1, and the square root of e to the y with respect to x is e to the stuff times the derivative of the stuff, employing the chain rule. So that tells me that dy dx is equal to 1 over e to the y. Now what is e to the y in terms of x? Well, we described it or defined it here, so this is going to be 1 over x. Isn't that nice? The derivative of the natural log of x is 1 over x, and the domain of that is that x is greater than 0. While we're here, I want to do a quick example. So of both of these. What would be the derivative with respect to x of e to the 5x? Well, it's going to be e to the 5x times the 5, where the 5 is the derivative of the stuff. So I would say e to the stuff times the derivative of the stuff. In similar fashion, what is the derivative of 1 over, oops, that's not what I want to say. What is the derivative with respect to x of natural log of, let's say, x squared plus 1? So if I were taking that derivative, it would be 1 over x squared plus 1 times the derivative of stuff. So 1 over stuff times the derivative of stuff. Now let's take a look at the derivative with respect to x of a to the x. And by a to the x, I'm saying that a is some constant greater than 0. And to do this, we're going to say the derivative with respect to x of a dx. Now all I'm going to do is a little bit of algebra trickery. Let's see. Let me come over here. A to the x equals, tell me if you follow this, e to the natural log of a to the x. See, the e and the natural log are inverses of each other, so a to the x equals e to the natural log of a to the x. But we can also use another property of logs and say this is x times natural log of a. So if you remember that a to the x is equal to e to the x natural log of a, that will be helpful here, because we'll say that the derivative with respect to x of a to the x is the derivative with respect to x of e to the x natural log a to that stuff, e to that stuff. And we already developed what the derivative of e to stuff is. It's just e to the stuff, now times the derivative of the stuff. Now natural log of a is a number, and that sometimes confuses people. Like if I had e to the 2x and we were finding its derivative, it's e to the 2x times 2. So here it's e to the x natural log of a times the natural log of a. That's the coefficient of x. Now that's a little bit awkwardly written, so we already know that e to the x ln a is actually a to the x, but now we have this trailing natural log of a here. So I'm just going to come down here to write it. The derivative with respect to x of constant to the power of x is equal to a to the x times natural log of a. It's also, I think, worth noting that if we said e to the x, where e is the constant, that would be e to the x times natural log of e, and natural log of e is 1. And to be consistent, the domain of this is all real numbers. X is an element of the reals. Last one, the derivative with respect to x of log base b constant of x. You will notice just initially though that x has to be greater than 0. Now we're going to find our derivative. Now the trick here is there is no trick. Instead of writing log base b of x, we're going to use the change of base property, and we're going to change the base to base e. So this becomes natural log of x over natural log of b. I had to come back, the phone was ringing. Natural log of x over natural log of b. That's the change of base property. Now natural log of b is a constant. It's like natural log of x over 2. So I'm going to factor out the constant, natural log of b, times the derivative with respect to x of natural log of x. So we have 1 over natural log of b, then times the derivative of natural log of x, which is simply 1 over x. And that's the final result. So summarize that the derivative with respect to x of log base b of x is equal to 1 over x times natural log b, and of course the domain is that x is greater than 0. Add these 4 to your book of memories. See if you can write these down before I get to say them. The derivative with respect to x of e to the x is e to the x. The derivative with respect to x of natural log of x is 1 over x. The derivative with respect to a to the x is a to the x natural log of a, and the derivative of log base b of x is 1 over x natural log of b. As far as domain, here x is an element of the reals. The only tricky one is here, because the original one only allows for x values greater than 0, so too must the derivative only allow for values greater than 0. Here, x is an element of the reals, and here x is greater than 0. Again, because the original only allowed for positive x values, so too must the derivative. So stay tuned for some